Hi, Honors Algebra 2 students. We're in Chapter 6, Day 12 notes, and we're going to focus in this lesson on solving exponential and logarithmic equations. Besides all the exponent properties, log properties, and various ways in which we've solved exponential and logarithmic equations so far, there are a couple more things that I need to mention that we might make use of in the examples that we're going to do today, and those are written at the top. So one thing we need to know is that if a to the x is equal to a to the y, then x is going to be equal to y. So in other words, if we have an equation and our bases are the same on either side of that equation, then we can set the exponents equal to each other. And then something similar to that is if log base b of a is equal to log base b of c, then a is equal to c. So in other words, if we have a log equation, here we had an exponential equation and the bases were the same. Here we have a log equation and the bases are the same. If that's true, then we can set the arguments equal to each other. And again, these are just additional things that we may encounter in the examples that we're going to do, and they will help you in some of the problems that you'll be doing in the assignment as well. As we get started with our examples, the instructions say solve the following equations, no calculator allowed. So if we look at this first example, if we have the ability to rewrite both sides in terms of the same base, then we could potentially make use of this property up here. All right, so let's see if we can do that. We could rewrite the square root of 5 as 5 to the 1/2. All of that will still be raised to the x plus 6. And then we could rewrite 125 as 5 cubed. All of that would still be raised to the x minus 2. And if you notice, I've now written both sides in terms of the same base, which in this case is 5. So based on this property up here, it says I can set those exponents equal to each other. So when I go through and I do that, then I would have 1/2 times the quantity, x plus 6, make sure you put that in parentheses, is going to be equal to 3 times that quantity, x minus 2. And the reason I'm multiplying those, remember a power raised to a power, we're going to multiply the exponents. A power raised to a power, we're going to multiply the exponents. And I can set the exponents equal to each other because of this property up here. I have a common base, so I can set the exponents equal to each other. But make sure you realize that you're multiplying them, number one. And number two, make sure that you realize that this 1/2 has to be distributed to the entire x plus 6. And this exponent of 3 right here has to be distributed to the entire x minus 2. All right, so if we go through and distribute, we'll have 1/2 x plus 3 is equal to 3x minus 6. If I get my variables on one side of the equation and my constants on the other, I'm going to have 9 is equal to 5/2 x. And then if I multiply both sides of the equation by 2/5 to get rid of the 5/2, I'm going to have that x is equal to 18/5. Notice all of that being done without use of a calculator. All right, in the next example, I have log base 2 of 7 plus log base 2 of 3 is equal to log base 2 of x. So the first thing we want to do is we want to condense the left-hand side of that equation into one single log expression. And I can do that using the properties of logarithms that we've learned, because notice that both of these terms are log base 2. So if we condense that first, we'll have log base 2 of 21. I'm going to take the 7 and multiply it by 3 and get 21, and that's going to be equal to log base 2 of x. And if you notice, both sides of my equation have a log expression on each side, and they're both log base 2. They're the same base. So if you notice up here, this property was telling us then that we could set the arguments equal to each other if that was true. So we have a log on both sides of the equation. They both have the same base, in this case 2, so we can set the arguments equal to each other. And when we do, in this particular case, we're done. Now, in some cases, we might have more solving to do after that, but in this particular case, we're done. So our answer is going to be equal to 21. As we look at the next example, it may look a little scary, but let's break it down. So if you notice, the left-hand side has log with a base the square root of 3 of x. Then we have 3 terms on the right-hand side. They're all log terms, and they all have a log or a base of the square root of 3. So what we're going to do is we're going to condense each side of the equation first. So we would have on the left-hand side log with a base of the square root of 3 of x. And then on the right-hand side, if we condense this, and we can use log properties to condense this because all of these are terms that have a log base of the square root of 3. So we're adding right here, so this means we're going to multiply the arguments. So we're going to have log our base of the square root of 3. We're going to multiply the 2 and the 9 and get 18. And then we have a subtraction symbol here. That means we're going to divide then by that argument, which would be 3. And then let's rewrite it a little bit more. So we'll rewrite it in this fashion so that we get just a 6 right here. And then again, if we look at it now, we have a condensed left-hand side, a condensed right-hand side. Both sides of the equation have log base 3 of something in them. And so we can now set the arguments equal to each other and get that x is equal to 6. That will be my final answer. In our next example, if we take a look, we once again have 2 log terms on the left-hand side of the equation, 1 log term on the right-hand side of the equation. If you notice, each of these terms has the same base for the logarithm. It's an implied base 10. So as long as they have the same base, on the left-hand side, for instance, we can condense those expressions. So log base 10 of, if we are subtracting right here, we know based on the log properties that we've learned that that means that we are going to divide the arguments. So x plus 4 quantity squared divided by x plus 4. We'll come back and simplify that in just a moment. And that's going to be equal to log of 5. So now I have simplified, condensed, in other words, the left-hand side of the equation as much as I can, and the right-hand side was already condensed. Notice that I have a log on both sides of the equation, and it's base 10. So now I can set the arguments equal to each other. Now one thing I just noticed before I set those arguments equal to each other, maybe I want to simplify the left-hand side just a little bit more. This entire argument right here, we could simplify a little bit more because x plus 4 squared divided by x plus 4 is going to simply be x plus 4. So let's simplify that a little bit more. And then I can take those arguments, set them equal to each other for the reasons that I just stated. And when we simplify or solve this now, we will get that x is equal to 1. So sometimes after you set the arguments equal to each other, you may have a little bit more solving to do before you get your final answer. In our next example, if we take a look at it, we have 2 log terms on the left-hand side. They both have base 3s, so we will be able to condense this using our log properties. On the right-hand side, we have a single log expression, but notice it has a base 2. So we'll come back to that in just a moment. Let's first condense the left-hand side using the log properties that we know. So if we have a subtraction symbol right here, that means we can divide the arguments when we do our condensing. So we've got log base 3 of x minus 2 divided by x plus 1. All of that is my argument, and that's going to be equal to log base 2 of 1/4. Now let's talk about what this means. This means 2 to some power, some exponent, is equal to 1/4. Well, what is that? That's actually a negative 2. All right, so again, maybe you need to write a little bit more out, 2 to the x is equal to 2 to the negative 2, because I could rewrite 1/4 as 2 to the negative 2, but in the end, x is going to be equal to 2. So in other words, log base 2 of 1/4, again, conceptually, what does that mean? 2 to some exponent is equal to 1/4. What is that exponent? it's going to be -2. And I forgot the little negative right here. All right, so that's going to be equal to -2. So if you have an equation that you need to solve and you have one base on one side of the equation and one on the other, with what we will be giving you in the assignments, you will be able to do something to evaluate one of them. Now, whether you need to write all of this out or not, that's up to you. You may and hopefully will be able to just think through what does this mean and come up with the fact that that represents the number -2. If you need to write any of this out off to the side, feel free to do so. And remember to come back and put that negative sign right there. I said it, I believe, but I did not write it initially. All right, so now if we take a look at this, if you notice, we've condensed or simplified the left-hand side of the equation as much as we can, and we've also done the same thing with the right-hand side. So now if we take a step back and look at it, our left-hand side is a term that has a log in it. The right-hand side does not. So in most of our examples earlier today, we've seen that the left-hand side, once we simplified it, had a log term in it, and so did the right-hand side. But in this case, one has a log term in it and one does not. So how do we handle that? Well, we go back to what we learned early on in this chapter. We take it from log format in what our equation is initially written in, and now we change it to exponential format. So this would be rewritten as 3 to the -2 is equal to x minus 2 divided by x plus 1. And that is simply taking this equation from logarithmic format and writing it in exponential format. And then let's go through and keep solving. So the 3 to the -2 could be written as 1/9. Because remember, that would be 1 over 3 squared if I get rid of the negative exponent. So that's 1/9. And then if I cross multiply and solve, 9 times the quantity x minus 2 is equal to x plus 1. If I distribute, get my variables on one side and my constants on the other, I'll get 8x is equal to 19. So x is equal to 19/8. Before I do the last two examples, I want to mention the following. The Day 12 assignment has a lot of problems on it where you are solving exponential equations and logarithmic equations. So you will be using everything you've learned up to this point in that regard. The examples that I've just done are new things that you'll be encountering on that assignment that you had not seen prior to this. But I do want to emphasize that many of the things that you've learned prior to this, as far as solving exponential equations and logarithmic equations, you will also be using, but you'll be using that in addition to the examples that I just showed you and the new things that we've run into on this video that you had not seen before. Our last two examples are review. We had a prior lesson where we talked about a common log, which has a base of 10, and a natural log, which has a base of e, and going through and simplifying things using those. And you were introduced to a little shortcut, and you were even given an explanation at the end on why you could think about, or why that shortcut worked the way it did, a way you could think about it, in other words. And since then, you've learned some log properties so that there are even more ways in which you could go back and think about why the shortcut works the way it does. But regardless, we want to review what that shortcut is. So when we take this first example, log of the 5th root of 10, we talked about if we can rewrite this argument in terms of base 10, remember there's an implied base 10 here, if we can rewrite the argument in terms of that same base 10, that will help us be able to use that little shortcut. So the 5th root of 10 could be written as 10 raised to the 1/5. And since the implied base 10 for the logarithm matches the base for the exponent, our answer is going to be the exponent. So our final answer for this will be 1/5. All right, in our next example, we have a natural log of 1 divided by e to the 8th. So we could rewrite that as natural log of e to the -8. And for natural logarithms, we have an implied base e right here. and apply base e right here. So if the base for the logarithm matches the base for the exponent, the answer will be the exponent, in this case, -8. All right, now since I'm the one that did the video for this topic in the past, and I did show you the shortcut, and I did give you one way of thinking about it because of what you had learned up to that point, I did hold off on showing you another way of why this works the way it does, because you didn't know all about the properties of logarithms at that point. So let me just offer one more way you could think about this. I feel like the more pieces you can put together regarding logarithms, the more ways in which you can think about them, the deeper your understanding will be. So if we go back and let's say we do rewrite this initially, just like we did on this one, log of 10 to the 1/5. Okay, so in other words, take it out of the radical format right here and write it as log of 10 to the 1/5. Okay, well, using properties of logarithms, that 1/5 can come out front. So we have 1/5 times log of 10. Well, knowing what you know about logarithms now, what this means is, and remember there's an implied base 10 right here, what this means, what log of 10 means is 10 raised to some exponent is equal to 10. 10 raised to some exponent is equal to 10. What is that exponent? That exponent is 1. So 1/5 times 1 will be equal to 1/5. So the way I'm talking about it right now is, using properties of logarithms and then talking about fundamentally what this means. This means 10 raised to some power is equal to 10, or 10 raised to some exponent is equal to 10. What is that exponent? 1. In other words, log of 10 represents the number 1, and then I can do that final multiplication at the end. So yes, by all means, you can still use the shortcut that was originally taught to you. In addition to that, or instead of, you can look at it the way that I offered at the end of that prior lesson where I talked about the shortcut. Or you could even think about it as I've offered right here, right now. But again, I feel like the more ways you can think about these, the deeper your knowledge will be, and I want to pass those things on to you so that you can figure out which way resonates with you in your understanding. All right, so this wraps up the Day 12 notes.